My name is Hansen. I'm a consultant with Progress Federal Solutions. I've been working with Marklogic building and managing solutions for roughly 10 years now, mostly in our federal space, and currently I'm supporting one of our largest federal customers. So it's here to talk about monitoring and managing and providing reliability at scale with Marklogic. So we've got a number of customers across a variety of industries that rely on Marklogic for large-scale, reliable, constantly uptime, mission-critical environments. The concerns and things that you would see on a smaller scale cluster are a little different sometimes than on larger ones. But some of these customers manage billions of records, thousands or tens of thousands of transactions per second. And so I wanted to go over some of the things that they've done to be successful and some configuration items that you can look at when you're looking to grow and manage a larger system. General methodology applies whether it's large or small. You need to have a defined goal, test, measure, repeat, incorporate those changes, have a baseline so you know when you're improving or when you might be actually degrading from a certain change. And then taking the lessons learned as you've gone through that and incorporating that into your monitoring and alerting. So things that you've seen in the past, you're alerted for as they might happen in the future and you're not caught off guard. So the definition of success, trying to figure out what's your goal, what does the system actually have to do, what are your benchmarks? For some customers, they have a large amount of data that they need to be able to process within a given window of time. For other customers, there's a certain set of concurrent users and transaction rates that they need to be able to support. Whatever it is, it helps to actually have that goal in mind and then know that you can develop, test, and prove that you can handle not just those loads, but then start to look at what does the future look like? When are we going to get a point where we need to consider scaling? Are we still meeting our SLAs but getting close? Because you want to try to plan ahead, especially for some of our large government customers. Procurement is often a challenge. So you may know that you need more, but you need lead time of 6 months or even a year to be able to get some of that equipment. Running in cloud environments does make that a little bit easier. You've got some dynamic capabilities, but it still is not something you want a surprise on a Sunday morning. You want to be able to plan for those events. So the first thing, given your goals, trying to figure out how do we know that we can meet it? Performance tuning and testing is critical, and if at all possible, you should use production size environments with production size data, ideally actual production data. Generating a mountain of dummy test data is helpful, but it doesn't always have the variability in values. Your caches may not behave the same way. Bugs and issues that have crept in over years may not be easily reproducible in a test environment unless you've got the actual data that exhibits those behaviors. So I can't stress that enough. If you can, try to test at the same scale with the same data as possible. Marklogic provides redaction, which makes it easier to take production data and sanitize it, keep sensitive information like PII masked and protected, but still have the same general shape and behavior for the overall system. But in general, like going through testing, you want to first identify how the system behaves in a baseline state, and then as you decide to make some changes to see if it's going to improve or degrade. Sometimes it's not a simple answer. You may get higher throughput, but then you have larger resource demands, and then you have decisions to make about, is this an acceptable change? Is it worth the cost to say need to scale the system to meet those demands, or are there other ways and alternatives to meet that? And we'll get into some details further. Besides meeting your benchmarks, it's also important to test to failure. Things happen, unexpected demands come in. If you're a system that's exposed to the internet, oftentimes, if you've got a large enough user base, there's a general flow of traffic, but things happen. You might show up on a Reddit post and get a flood of traffic, whatever it is. Understanding how far the system can go and how far you are away from those limits, and seeing where your bottlenecks are. Some things are under your control if you're looking at just being the Marklogic DBA, whether that's allocating hardware, changing configs, and tuning settings. Some things are out of your control and above the stack. Working with one customer, we had done all of our due diligence. We knew that the system was tuned and primed and ready to handle whatever we threw at it. And then we had an event where the clients were timing out, system wasn't working, everyone's confused, and they're like, what's wrong with Marklogic? We're like, Marklogic's fine. It turns out there wasn't sufficient bandwidth to allow the traffic to get to Marklogic. So it was sitting around doing what it needs to do and was never really stressed. Once that was identified, they opened the floodgates, and then the system actually started humming and response times returned to normal. Everybody was happy. But those are the kinds of things that not just testing in isolation, but testing your full system can help reveal where those bottlenecks are, and whether you need to adjust or just to understand your limits. On the same token, you may want to place some kind of throttle and prevent a surge of traffic from making it through so that you can maintain stability of the system and prevent something from being greedy and running out of resources. But the other benefit of pushing your system to its limits is also to see what it looks like when it breaks. You'll get a good idea of the types of error messages, the types of performance metrics. What does the system look like when it's struggling? It's easier to collect those and understand those patterns in a non-prod environment when there isn't as much pressure to fix it immediately. And if you've seen it before, you'll know how to react, you'll know what steps need to be taken, and how long it's going to take to get back to normal. So Netflix has the concept of chaos monkey, where they intentionally introduce failure as a means of verifying that the system is resilient and can handle such failures. You can and should do the same thing. If you think of something that could go wrong, test it. What happens if I lose a host? What happens if the hard drive is corrupt? What happens if a network card goes bad and starts spewing nonsense or dropping packets? Like I said before, observing those behaviors and understanding what your thresholds are, what needs to be alerted on, what's an emergency that you should wake somebody up and is going to be a site outage, and what is a concern, but maybe you want to send a warning email that someone can pick up when they get into the office. Being able to discern what's an emergency and what's an inconvenience and how resilient your system is. There's a lot of features built into Marklogic that can automatically handle failure, and the system can move on. But there are times where you may hit something where it needs manual intervention, and understanding when that occurs, it's much easier to have practiced that and gone through those exercises. So when it comes to tuning and scaling, there's a variety of levers and options, and I'm going to go through some of those and explain pros and cons and trade-offs. The first one being query tuning. It's often the easiest and cheapest way for you to be able to squeeze more out of your system and make it do more with less and avoid having to scale out. Of course, you can always throw hardware at a problem, but even that, at a certain size and scale, it still isn't enough. If you're going to select 1 billion records to come back, you're going to hit a timeout, you're going to run out of memory. So thinking about how to place limits and throttles, query canceling based on thresholds, anything that you can do to stabilize the system. If you can reduce your response times, that affords more queries to come through with the same amount of resources and get greater throughput. Like I said, it's sometimes the cheapest option to just make sure that you're eliminating filtering where possible. If you can rely on indexes, apply indexes instead of value queries, all of those things to streamline and get as close as you can to sub-second response times. So looking at the organization and the architecture of your clusters, smaller scale clusters, if you've got 3, 6, 12 nodes, you may want to go with the general purpose blended E and D node. When we talk about E nodes, those are the evaluators that the requests from the outside come in, execute whatever modules, JavaScript or XQuery, and then distribute those queries out to the D nodes, the data nodes that house all the forest and the content. As you get to a certain size and scale, it can sometimes be advantageous to have dedicated roles for those hosts. It is much less impactful if somebody were to run an unapproved out-of-bounds query selecting 5 billion records and crashing an eNode. If an eNode goes down, traffic stops routing to it, you can spin up another one. It's a lot less impactful to the system than if a D node goes down, and then if you've got HA replicas, things are opening up, there's delays, and it can impact more than just that affected host and consumers. It also affords, because it's much easier to add in eNodes, to look at auto-scaling to meet the demands. So if you have fluctuating resource demands, especially even higher volume daytime and less in the evening, you can look to recoup some costs, save some money by scaling in and then later scaling out to meet demand. It's much easier to scale with eNodes than it is D nodes. There's some overhead involved and some complexity, especially when balancing replicas where that's not always as easy and usually not as necessary. The size of your data doesn't usually grow or shrink with the same velocity that your traffic might. But organizing those settings in the group caches, by default, your caches are set as automatic, which is a blended ED node. If you know you've got specialized hosts that are only serving eNode traffic, selecting eNode is a good choice. Same thing for dnode. What that will do is shrink some of the caches that are less used for those other jobs and increase the caches that are used for what it needs to do. So for the eNode, your expanded tree cache will be larger, and these are automatically adjusted as the host comes up for what resources it sees are available. So if you happen to scale up and change the instance size, the caches will get adjusted for you. It's generally an easier way to go. There are times, if you're looking to micro-optimize or you've got specific SLAs, where you may want to take control and provide custom cache sizes. For one of my customers, we did just that. We were trying to eke out a couple thousand extra transactions per second, and every bit mattered. So we looked to set some custom sizes, some additional cache partitions, which would allow more concurrency, and we're able to eke out just a little bit more performance. But a word of caution, the more partitions you have, you're dividing your available cache into smaller pieces. You need to make sure that each cache partition is big enough to hold what it needs to do, especially on the eNode side. If you're pulling back large result sets, that needs to be able to fit into the expanded tree cache. Background I/O is another one that, especially for larger scale systems, that you should take a look at. By default, it's unbounded. The background I/O is a governor that will set a maximum throughput that can be used for activities such as merges, backups, and restores. I've seen plenty of customers who find that the system is generally working fine, but when they go to do a massive reindex and there's lots of merging activity, disk becomes slow, they start seeing weird issues where they're exceeding capacity, or if in Windows, when the backups are running, incrementals start chewing up I/O and can cause some impact to the system. So the background I/O allows you to set a throttle and say, don't use more than a certain amount. This will, because of that limit, for something like a backup, it may stretch your backup times, but it helps ensure that it doesn't push in and steal resources from online traffic. And then just a quick note about the file log level. The default is info. It's generally recommended to run at debug. If you were to run into a problem and need to open a support case, the first thing that progress support's going to ask for is a support dump and debug level logs. So it's much easier to have that in place before an event occurs and have the information to provide to them, rather than be cut short with limited information. The more information you can provide, the easier it is to provide support. Some people are a little cautious, thinking that debug may fill up their log mounts and cause all sorts of issues. For the system level error log, debug messages are not super frequent. And like I said, it will provide some additional details that can be very helpful if and when you run into some issues. For organizing databases, there's a default location when you go to create a forest where everything will live. Depending on the size and scale and the number of databases and the number of forests you have, if you're looking to balance the amount of disk activity, I/O, and throughput, you could look to assign forests to specific data mounts. So especially in cloud environments where there's a limited set of IOPS and throughput, if you were to pile everything onto one, you may find that you're starting to hit limits. So you can separate those and have isolated, dedicated workloads. Another option is the fast data directory. This was originally built with the intent of balancing cost and performance with solid state and spinning disk. So you would have your initial I/O for merges and inserts and updates go to the fast and efficient drive, and then as they merge up and fill, they merge out into the larger, more static data mounts. You can still use this even in cloud environments, especially with like GP3, where you have control over your IOPS and throughput. You may dedicate a certain amount of GP3 with higher IOPS than the larger, more expensive data mounts where you can control that. So those are things that you have at your disposal, especially when looking at different workloads where I/O demands are heavy. In-memory settings is another one that default setting has a certain size and threshold for a number of meters. If you've got debug logging, you'll see XDMP, in-MM, something after that, and that'll give you a clue as to what is the metric that triggered the in-memory stand to flush to disk. It's a little counterintuitive, but in-memory stands can be less efficient than on-disk stands. So when under very high volume, where throughput matters, you may find that your system performs better if you keep your in-memory stands below a certain threshold and flush to disk faster. Once those stands are on disk, they have a chance to get merged up, consolidated, and can perform better than the in-memory stands. The converse is true, where if you're worried about I/O and how much activity there is, you can look to increase your in-memory sizes, hold more before it decides to flush to disk. So depending on your workload, that's a dial that you may want to turn up or down and observe the effects. Index detection by default is on. This is something that as the forests are mounted, there's some inspection and housekeeping that goes on to take a look at the data structures and see if it matches the configuration of your system. In a development and test environment, this can be convenient. This allows Marklogic to understand even if you have a range index in place, if it hasn't finished reindexing, it shouldn't try to use that range index. You can get errors and say that the index is not defined. In a more controlled environment, like production hopefully, if you were to turn that off, you can bypass some of that overhead. And what this means is forests can open and mount faster. And in a HA scenario, if you've had a host failure and some other hosts are taking over and trying to mount as quick as possible, and you want to minimize the downtime and the interruption, having index detection disabled can bypass some of that and get started much quicker. Shutdown on storage failure is a newer feature that is by default disabled. This was mostly for backwards compatibility. I have experienced an issue in one of my production environments where we needed something like this, and it was actually the impetus for getting this put in place. If a host is online and responding to heartbeats, it's a part of the quorum. Queries that get distributed to a D node, all the E nodes will sit and wait for a response. But if you have stalled or ineffective I/O, then everyone just sits and waits for an answer. If it's not going to come back, it would be much better to have that host terminate and trigger a failover event and move on. So this is something that can, in an automated fashion, prevent you from getting a midnight phone call and asking you to go find the sick host and kill it. When it comes to app servers and scale, every application server has a configurable number of application threads. This will control how many concurrent query executions can occur on that particular host. So the more eNodes you have, multiply that times whatever your configured thread count is. If you need extreme high volume, you may decide to increase that thread count and allow more concurrent executions to allow you to get more throughput. And you may look to differentiate based on the type of traffic and the types of queries that go to particular app servers. You may want to throttle big, expensive aggregate queries that are going to run for minutes. You don't want those to sit and hog a thread and prevent some of the quick and easy requests from coming in, so you can differentiate where you want to balance those. The default time limit for a request is 10 minutes. If you're running a high throughput responsive system, that can be overkill. And if there is any sort of blip or interruption, it may be better to fail fast and give your client a chance to retry rather than to wait minutes just to get an error. Sitting on that thread means no one else can make that request. And if you're not willing to wait 10 minutes, then you should shrink that down to something more appropriate to what the client's going to be configured to wait and listen for. Distribute timestamp is another one that by default is set to fast. What this means is as each of the hosts that are connected to each other exchange heartbeats, they send updates for if any of the timestamps have moved forward. With MVCC, you get a view of the data as of that timestamp. In a load-balanced, high-throughput environment, it is not uncommon to see an initial request come in to make a change that lands on one node, and then a subsequent read that hits a different node. And if that's within that 1 second threshold, it may not see that change. Customers have gotten creative by applying 1 second delays, which is terrible for throughput. You're just gonna sit there and wait before you make another request. Other fixes have been to apply a query in update mode, which now forces a lot more locking and a lot more activity. A simpler solution in many cases is to change it to strict. What this means is as the transaction completes, the timestamp is immediately distributed. And so you're more likely when you make requests that are load balanced across many hosts that they're going to see a timestamp that's updated and a view of that data that's more current. Just a quick note about the authentication scheme and the number of requests that come in and out with the application servers. By default, XCC and HTTP are set with digest. What this means is that the initial request is met with a response to provide a nonce that's used to help hash and encrypt the authentication values for subsequent requests. If you don't have a load balanced environment, every time, connection pools, every time you go to make a connection, you're basically making 2 requests. It's much more efficient in many ways if you have, and secure, if you have HTTPS, TLS connections with basic. It shouts the connections as it makes the call, and there's less overall traffic. It also can help avoid confusion about your request rates when you're looking at whether to include or exclude those initial calls with a 401. So it can just be a little easier on monitoring and make things simple. In a high throughput environment, you're likely to have a load balancer. Something that I've seen with a number of customers is confusion about why some of their eNodes are getting auto-healed at random points. If they go look, there's no signs of distress, the host looks healthy, but their load balancer keeps terminating and spinning up new ones. This has recently changed in newer versions of Marklogic, but previously, by default, the health check application server was set with 8 threads. If you're using that health check to determine the status and the health of multiple application server ports, you can sometimes overwhelm that application server, and that leads to delays. It gets marked as unhealthy and gets auto-healed. So that would be one of the first things I would check is bump up the thread count, allow more concurrent requests coming into your health check so it can ping and see healthy and keep those hosts alive and avoid unnecessary interruptions. This next one, it is critical to align your client timeouts with your load balancer timeouts and your Marklogic application server timeouts. If you have the default 10-minute timeout on Marklogic and you have a client who's going to time out after 30 seconds, or even a load balancer that's going to cut the connection and return a gateway timeout, Marklogic will continue processing that request on the back end for up to 10 minutes. Then it'll return a dead letter. The client, if it's going to retry, is going to send in another expensive, slow query, and you can escalate and spiral out of control. It's much better to ensure that the load balancer is willing to wait long enough for however long you're willing to let Marklogic to execute your queries. I'd mentioned before connection pools. Under extreme load, very high volume, if you're not using connection pools, it is very easy to exhaust your ephemeral ports. Every time you go to make an HTTP connection and establish a socket, when you close it, there's a timeout window before it's officially reclaimed. So if you burn through those really fast, things that I've seen in the past are you'll get amazing rates and then no traffic, and then amazing rates and no traffic, and it just oscillates. And that's because it's waiting for those closed ports to be reclaimed and to be available so that traffic can continue. By using a connection pool and reusing an open connection, you can make multiple requests over an established socket, and it's a lot less stressful on the system. You're a lot less likely to run into those resource constraints. I mentioned before about however you want to manage timeouts, errors, and issues, having a retry strategy that makes sense and doesn't push your system from bad to worse. If there's an interruption, it isn't always the best idea to retry immediately and to retry infinitely. Have some kind of threshold set, potentially exponential decay, so that on subsequent retry, it has enough time to allow the system to recover and become available, or for a queue to drain or whatever it is, and not make it escalate from bad to worse. If high availability is a concern, especially in a cloud-hosted environment, there are options for an AWS availability zones. These are effectively separate data centers that are close enough to have very good response times. This insulates you a little bit from any kind of infrastructure issue in one of those particular AZs. It's possible to configure your system where you could lose a third of your hosts and still remain online and performing normal operations. It is critical that you actually test and validate your HA scenarios. It's very easy, especially as the number of nodes increases. If you happen to have multiple mounts, multiple nodes, multiple availability zones, to make a mistake in your alignment and your strategy of striping your HA. So proving that you can pull the plug on a third if you take a host down, what the impact is on the others is critical. And then just a note on watching the resource utilization and balancing not just how fast can we go and how far can we push these hosts before they fall over. What does it look like if there is a problem, if you do lose a host? Depending on how you've got things organized, you could potentially double the load when an HA replica opens up and takes over for one of your dead hosts. If you're already at 80-90% CPU, you're not going to have the resources to be successful for that HA replica to open and service traffic and meet your SLAs. You may wind up having a domino scenario where one node goes down, the other picks up, it runs out of memory, that node goes down on down the line. So you should be able to, depending on what your needs are, validate and verify what kind of rates you can support, what kind of workloads you can support in an HA scenario. The time to find out is not in prod on Sunday. So there are a number of options available if you've exhausted your tuning and performance metrics efforts, and you decide you need to add resources. You can always scale up and make your instances bigger. You can scale out and add more. I had one customer who was dealing with an issue. They couldn't meet their SLA. They had a goal, and they were exhausting the resources. As a quick measure, they bumped up their instance types. They proved that that was successful, but that doubled their budget, and they weren't prepared for that expense. But this provided enough time for us to do some analysis, provide query tuning, look at changing some value queries to range queries to reduce the demands on the system, and then later bring it back down to the original instance type. So it can be at least a convenient way to provide temporary relief. One of my other customers found out that bigger isn't always better. One of the things we were investigating when trying to figure out how can we squeeze more performance and get more throughput, the idea was, well, let's just make them bigger, give it more memory, more CPU. And we found that we actually had a drop in our overall throughput. These were multi-NUMA systems. They were extremely large, and I think we wound up overwhelming a channel down in the bowels of the system. But we decided at that point it would be much better to look at scaling out. And I mentioned before, eNodes are much easier. You may find that your eNodes don't need as much horsepower as your dNodes. What's more important sometimes is just providing enough available connections. So shrinking to smaller instance types and adding more little pizza boxes rather than a handful of beefy servers can sometimes be fruitful. And then in a cloud environment especially, it's important to look at moving to the latest generation. There's a couple of reasons. If you're on 5-year-old equipment, your provider's not likely going to be refreshing and replacing as things age out and start running into issues. So you may find that your instance types aren't available when you need them if you're looking to scale. The other important thing is obviously newer generation hardware is going to have better CPU. They're going to be on networking equipment that has more specialized, better management and capabilities. So you've tuned and built this system. The other thing that's also important and making it a part of as you're building and tuning the system is monitoring, alerting. I mentioned before, as you see things go wrong, collect those, decide how those need to be turned into either an immediate alert or some kind of warning. You get a feel for the temperature of the system. You'll get an idea of what normal looks like. And so then you can more easily detect when you're starting to skew and then prepare for growth. When it comes for what to monitor, there's a big list. One of the things that I think besides any one specific item is the idea of looking to correlate behaviors. So if you see a pocket of slow executions, if that happens while CPU has shot up, and that is also when you see some XDQP restarts and the hosts are trying to talk to each other, that's a clue that it may be the system itself and not any one particular query. So if you look at host availability, obviously quorum messages will let you know how many hosts are online. If a host is struggling, there's probably other reasons for it, but signs and symptoms, if you see hung, canary, any kind of slow message, slow background, slow fsync, whatever that is, that host is likely under some sort of duress. One of the most important things I'd recommend is paying attention to the memory messages. Marklogic will warn you if it sees you're low on memory, and that isn't always what you think. Customers will look at free and see there's gigs available and say, I'm fine, I don't know what Marklogic's talking about. With these memory low messages, it'll give you an account of what the forest and files size is, how much you've got in anonymous, if any swap is consumed. The sum total of any of those things can actually be more than 100% of your physical memory. So it's not uncommon for some people that have ignored these messages to see memory low messages saying they're at 120%. This is kind of like driving with your check engine light on. You may be fine for a while until you're not. So In general, you want to try to keep that below 80%. That's when the memory low will start to be logged. And then start considering whether you need to scale up or out or control the amount of resources you're consuming. CPU load and threshold, obviously, I mentioned before, especially if you've got HA configured. If you go too much more above 50% CPU and you're gonna double the load on your host if you do have a problem, you're gonna have a problem. There's diminishing returns as you go higher in CPU in a hyper-threaded environment. It's not quite as efficient, so you may more than double whatever your load is. And just to be aware of the risks that you're taking if you're pushing the system consistently above the levels. There's plenty of messages to tell you about what your disk activity is looking like and how much throughput you're seeing, how many IOPS are being consumed. I will warn, it is not completely uncommon to see a slow F-sync once in a while. This is real. It means the system tried to write and there was a delay before it had a confirmed write. Those are very important to a database. If it's over the threshold, it's going to tell you about it. You may find that if it's 1 or 2 seconds and it's an occasional occurrence, that it doesn't impact your system and you're okay. But if you see that stretching into multiple seconds or happening extremely frequently, that's a sign that you don't have enough disk capacity to support the workloads that you're pushing your system to do. The disk failover and shutdown, that's where you'll start to see disk check settings. There's a default configurable threshold. You can still run into problems below that threshold that might interrupt and cause some challenges. So those are things to keep an eye on. And then I/O wait shows up under CPU, but is actually an indicator that you've got disk capacity issues. Many customers will look at just the top level CPU and assume that the server is really busy and that they're pushing their limits and not realize it's not the server and the CPU itself, it's actually the storage layer. So if you drill down and see out of my CPU, is it user, system, I/O wait? If you're spending 60% of your time in I/O wait, that means your server is busy waiting on the disk. And so you should focus on your storage layer rather than compute. With the application servers, depending on how many threads you've allocated, if you've got a surge of traffic that's beyond those available threads, those will queue. What the customer doesn't know when it makes that request is where they stand. Are they actively executing or are they sitting in the queue before it actually executes? So you may have fast executing queries, but too many of them that are still resulting in client timeouts. So to keep an eye on if you're queuing frequently, then that's a clue that you may want to look at adding some additional capacity or opening up for more concurrent executions. Request logs are an often underutilized feature. So there's a default threshold of 1 second on the 8000 port for anything that gets executed, and you can configure this on any one of your other app servers. It'll log not only the module and how long it took, but you can control the metrics from that query. So you can see how many locks did I take, what were the cache hit and miss ratio. So if you've got a slow query, you can look at some of those metrics and see if that makes sense. It's a way to record some of the things you might observe if you're doing query profiling. But being able to correlate those behaviors and see of the queries that are running slower, is it because of a particular set of metrics, or are they occurring at the same time? And like I mentioned, does that happen while other server metrics happen to spike up? And then obviously, you want to make sure your backups are working and you know if there's any failures. And just a quick note about being in a cloud environment doesn't mean that you won't have issues. In the end of the day, it's still just somebody else's computer. They're very good, in my experience, running on AWS is extremely reliable, but there are moments where something fails. They're usually quick to identify and react to it, but your system needs to be able to absorb or handle within thresholds or in an HA event, take over if something isn't performing. So for automatic failure detection and handling, Marklogic has a number of configurable thresholds for things. If there's an interruption in those host communications that's greater than the XTQP timeout, which by default is 10 seconds, Marklogic will attempt to disconnect and reconnect. If that takes multiple attempts and you stretch beyond your host timeout, that's when it gets voted out quorum, HA replicas open up, and the system moves on. If you're not monitoring your system, you can actually have an HA event and be unaware of it because everything continues to work, and then later discover we've got uneven resource utilization, we're not able to meet our SLAs, we forgot to flip the forest back over. So those are things to take a look at. It's helpful to have automated recovery and automated actions, but you need to be able to be aware of it so you know what's going on in your system. Disk availability, I mentioned. It's just another way for the host to say, if my hard drives aren't working, I'm not very useful as a database, so I'm going to take myself out of the pool and allow everyone else to move on. And if you happen to run out of memory, if you run a big, scary query that crashes a box, you can have the service auto restart and pop back up. The harder one to deal with sometimes are brownout conditions. So it's not a complete failure, but you just have degradation. The XTQP restarts and other things, if they're having trouble communicating, whether that's a bad network card, a bad port on a switch, whatever it is, every time there's an interruption, a query is going to get interrupted and have to retry. So you may see extended execution times, things just being slow and sluggish. Same thing, if there's delays in storage that aren't enough to trip your thresholds, that can interfere and cause degradation in performance. I mentioned before the request queuing. As issues are encountered, if you don't have the proper retry strategy, things can escalate and go from bad to worse. So with all of that taken into account, the other thing that helps when managing high scale, large systems is having some amount of operational maturity. You want to control what code gets executed in your environment. Exposing Query Console for random ad hoc queries is not always a great idea unless you're sure you've got sufficient resources to handle whatever gets thrown at it. Keeping an eye and understanding what normal looks like throughout the day. Some systems have very regular traffic patterns, and they know what the middle of the day is going to be a little busier than in the evenings. Those can help inform if you need to take some kind of action, like flipping forests. You may not want to do that at your peak periods. You may want to wait until there's a slower period, but still take care of it before your backups kick off. So having defined SOPs can make sure that there's fewer mistakes, that people know what to do, and that they don't necessarily have to wait for the one expert, that you can just have normal operations and get back healthy quicker. That's all I had for running through those. Here's some resources if you're interested in general, how Marklogic server functions, performance tuning, strategies. I've actually taken what I've done on several clients and baked some pre-built queries and index settings for Splunk. So if you're a Splunk customer, this can give you a leg up. And I think that's all I have. We got time for questions if there's any.
We have time for about one or two questions. And just to let everybody know, we will send these slides after all the presentations, the sessions today. So, question?
Hey, Matt. I was wondering if the threshold for determining when to use eNodes versus separating eNodes and dNodes, what if the threshold is changed?
Yeah, so there's no hard and fast rule, but I'd say if you're a 3-node cluster, spinning off one host to be the eNode and 2 for D may not make sense in terms of how much you're paying for a particular instance and the server license and everything else. And things can work just fine as blended ED nodes. You can run bigger clusters that may provide you even more application server threads if they're cheap and easy and you just need volume. So there's no hard and fast rule. It really does, unfortunately with a lot of things, it really does depend on what your workloads are, what your budget is, what kind of guarantees you need. You can make things work one way. I found that it's much easier, even just from the monitoring perspective, to have separate E and D, because they have distinct patterns for resource utilization. And I'll know if someone says, hey, CPU has gone really high, I can look and see on which type. If it's all D nodes at the same time, there's expensive queries running. If it's a single E node, somebody's running some big dumb query in Query Console and they're just churning butter. So that makes it a little easier sometimes. If it's a blended node and a single node comes up, then there's a question of, is it the query that's running happens to hit that box, or is it struggling because something is targeting a specific forest that lives on a specific host? So I don't know, I find that it provides some clarity.
So Marklogic 12, there's no any changes to that, to the recommendation?
So not for like whether to do that, but one thing coming that just came out with Marklogic 12 is the concept of dynamic eNodes. So being able to add and remove those a little more easily. Traditionally, when you add a node to the cluster, it updates the configs that has to get broadcast to all the other hosts. There's a lot of overhead involved in that, and it's persistent. With dynamic eNodes, you register a host that says, I'm going to start sending traffic, and it's allowed to broadcast that and receive, but you can take it out, and it's fine. There's a lot less coordination that has to occur, and so that can be a little more streamlined in terms of adding and removing hosts and being able to scale that up and down a little faster.
All right, unfortunately. All right, we have time. One more question, a quick question.
Thanks.
You mentioned value versus range queries a couple of times, and I'm thinking about when we're deciding which of those to use when either one could be used.
Yep.
I think in terms of the range queries are fast, but they consume more memory, and you talked about it as sometimes you want to reduce the impact by making a range query. Can you talk a little bit more about that?
Yeah, so that'll also does depend on the volume and velocity. If you've got ad hoc random execution for a value query, anytime you ask for it, if there's a miss, there's going to be an I/O, and then it gets populated in the cache. If you're going to pepper your system with a billion random social security numbers, that's going to potentially cause a lot of turnover and a lot of I/O on the system. That might be a more appropriate means of searching across a range index, because it's organized, it rips through it like memory. There's details on how some of those pages get turned over, but oftentimes it's much easier to leverage the index if you're willing to pay the cost on either storage and memory on the impact. There's always a trade-off, but some of it is looking at, do you need high volume, low latency, streamlined queries? I would favor range indexes, but obviously if you put a range index on every single element in your system, that's going to be a big and expensive operation.
Thank you.
Thanks, Mens.